Welcome to the AQtime Counters video. It will provide an overview of AQtime's counters and demonstrate how the profiling results generated depend on the counters used for profiling. AQtime's profilers can gather different kinds of information about the applications. Which characteristics the profile will measure depends on the selected counter, and the counter can be set by choosing an option from the Active Counter Profiling drop-down box in the Run Settings dialog that appears when you begin profiling. Currently, there are 13 counters available in AQtime. These counters allow you to time function execution times, measure various aspects of CPU performance, count memory page faults, and so on. The most frequently used counters are elapsed time, user time, and user plus kernel time. All of these are used to time function execution. The difference is in constituents of the measured execution time. The elapsed time counter lets you determine how fast your application executes the required actions in real time. It measures the time that has really elapsed between 2 points in the applications. The resulting execution time includes the time spent executing code in the user mode, time spent executing code in the kernel mode, and also time spent for execution of code in other threads. So let's talk a little bit more about that. In fact, the CPU executes only one thread at a time. The CPU executes the code of each thread for a very short period of time, and then switches to another thread, executes that for a short period of time, then to another thread, and so on. And since these time slices are very, very short, the threads seem to run simultaneously. Okay, so suppose now that there are 40 threads running in the system, and one of these threads is your application's thread. Alright, now imagine that the CPU executed several initial instructions of the profiled routine in your thread, but now the time slice given to your thread is over, and the CPU has switched to one of the other threads. Assuming that all the threads have the same priority, the CPU will return to your thread and continue executing your function after it goes through those other 39 threads. So before the profiled function finishes, the CPU may switch the thread context 100 times. If you use the elapsed time counter, the profiled time will include the time spent executing those other threads, as well as the threads of your own application. If you use the user and kernel time counter, profiling results will be made up of the time spent executing your application's code and the time spent executing the kernel code that was called from your code, but they will not include time spent executing other applications and time spent switching between threads. So this counter gives you the best estimate of your code execution as it includes the impact of other applications on it. If you only want to time the execution of your code itself, then use the user time counter. This counter ignores the time spent executing other threads and operating system code. The resulting time only includes the time spent executing code in user mode, that is, just your code. Using different counters, you can not only search for the application routines that are performing poorly, but determine the reason for this performance issue. For instance, if a function executes slowly, it can be caused by inefficient code, poor memory management, or call to a slow system function. Profiling your application with different counters will help you find out the exact reason for delay. Okay, so let's demonstrate how you can do it. In our demonstration today, we'll use an AQtime Counters demo application. Jump over to Visual Studio here. This is a multi-threaded application that demonstrates a situation that frequently occurs in real life, waiting for a thread. And the application runs 3 threads, and these threads are in functions thread 1, thread 2, and thread 3. Let me close the application, jump into the source code, and show that to you. Okay, so I've jumped into the source code here, and you can see right here we are invoking 1 thread, 2 threads, 3 threads. There we go. So during the execution, the application emulates a common wait for thread scenario. The thread proc 2 and thread proc 3 threads wait for thread 1 to complete and then continue running. As I've explained earlier, because switching between threads in real time, the executing time of thread proc 1 and thread proc 2 will include the time spent executing thread proc 1. To estimate the pure performance of these functions, you may want to exclude the time spent executing thread 1 from the profiling results of the other 2 threads. So let's see how you can do this with AQtime. First, I'm going to create a new project inside of AQtime, and then I'm going to add the module that we want to profile. So I'm just going to right click on the modules node here, say add module, and then browse out to where my application lives. In my case, it's right here, AQtime Counters demo.exe. Okay, now that we've got our code added, what we want to do is choose the profiler we care about. In our case, it's the performance profiler. And then we want to run that profiler, so I'm just going to click the run button right here. And now AQtime has popped up this run settings dialog, and it's here that we're going to choose elapsed time. Okay, so I'm going to choose that and then click the run button. Okay, now AQtime has invoked my application, and I'm going to click the start button. So now my application is going to perform some actions, and I'll wait till it's finished, then I'm going to close it. Okay, fast forwarded a little bit here. I'm going to click the close button. And now AQtime has generated some profiling results. Okay, so let's take a look at the results. In particular, we can see that thread proc2 right here is very, very slow. So let's take a look at what's going on with that function. And one of the ways that will help determine the cause of its poor performance is to look at its source code by clicking down here on the editor palette. And what we see here on the left side of the editor are profiling results for each individual source line. So we can see that according to this data, the slowest line of the thread proc2 function is a call to this wait for single object method right here. Now in reviewing that method's code, what it does is wait for thread 1 to finish. That is, thread proc2 continues executing after thread proc1 finishes. So when we use the elapsed time counter, AQtime will include the time spent executing thread proc1 in thread proc2's function time. That's why this function is taking so long to execute. Also notice that we have a call to a sleep function right here inside of thread proc2. This function suspends the execution of the current thread until that timeout interval passes. So the elapsed time also is taking that time into consideration. So that time is also being taken into consideration as well. If you don't want to include the time spent executing other threads or sleep functions, you can use the another counter in order to get your information. For example, we can use user plus kernel time. Now for each application routine, this counter will perform measurement within the routine's thread only, but not in other threads. So this counter is going to time the code execution in user mode and the execution time of operating system functions that get called from your code. So I'm going to reprofile my application using this user plus kernel time counter. Okay, I fast forwarded a bit and you can see now our timings are much slower than they were before because we aren't including the time spent executing other threads. However, we can see that the execution time of thread proc2 is still considerably bigger than thread proc3's function time. So let's determine the cause of this. If we compare its time and time with children values, we can see that the bottleneck does not take place within the thread proc2 function, but rather inside some of its child method calls. Because time, that's how much time was spent executing thread proc2. Time with children includes calls to other functions within thread proc2. So to see what child routines this method called, I'm going to switch down here to the details panel. And you can see here that thread proc2 has only one child function, and it's called read data from file. So it's pretty obvious that this is where the bottleneck is. So let's look at the profiling results for that particular function. So I'm going to double click on read data from file right here, and then we'll click here on the lines tab. Now as you can see, the majority of execution time happens right here on line 203. To view the actual source code of this line, I'm just going to double click on it. And in reviewing this code, it looks like the code is making a call to the read file function. And this is a Windows function that calls a Windows routine that actually handles reading data from a file. So when the application calls the read file function, it switches from user mode to kernel mode. Since we were using the user and kernel time counter, the profiling results included the time spent executing both our application code and that operating system code. Now, if you don't want the results to include that time spent executing the kernel code, we can use the user time counter. So what I'm going to do now is reprofile my code again, but this time I'm only going to use user time. Okay, I've fast forwarded a bit, and you can see here that the call to thread proc2 is now only taking 1.56 milliseconds. So it's much faster now. And if we look at our details for this, again, we know that we are calling the read data from file, and we can see here on the lines code, line 203, the execution time is down to about 1.25 milliseconds. So from here we know that the reason thread proc2 is so slow is because of that call that's being made to a slow system function, in this case the read data from file. This concludes our video on using counters with AQtime. We hope you found it useful. If you have any questions, please don't hesitate to contact us at the address on your screen. We wish you luck and hope you enjoy profiling your applications with AQtime.